not f times, but it's f of. So what you were supposed to do f of 2 was a good old substitution. And a good old substitution says, I hear Andrew and Alexis, it's okay, they're talking it out. For some reason, this day and age, people are horrible at whispering. There we go. What this formula says up above is it's a pattern. It says, hey, f of whoever you put in my spot, I'm going to square it, multiply by 3, and then subtract 1. Wait, was there a very particular order to how I just said each of those operations? Did you hear what I said first? Excellent. I said square it, and then what did I say next? Multiply by 3, and then? So the way that I can show that in my work is I can put that 2 in the x spot. So that way it's his turn, not x's turn. That's what was going on a second ago. But it's 2's turn to be squared, then to be multiplied by 3, and then to have 1 subtracted. Final answer was 11. Now pause and double check. Did you realize it wasn't saying f times 2? It was saying f of 2, which means for every single problem we're about to do, which is kind of just reviewing old skills that we need to use for this section and this lesson, every single one is going to say, hey, I'm using the guy up above. So every single one should be saying, I need to square, multiply by 3, and then subtract 1. Square who, multiply who by 3, and subtract 1 from who? Whatever's in the parentheses. So what was there to begin with? 2. What's there next?
1.
Wait. How hard is that? Because can't I just square the b? Multiply by 3, subtract 1, and say I can't do anything because I don't know what b is. Okay. Cool. Ponder that as I answer Armando's question. Armando, what's that?
I was going to say, what if there should be a 1? Understood the 1 there?
There is a minus 1 there. Oh, it could be a 1b, but since it's not just the number 1, I can't take the b away because the b still needs to stay. Does that make sense? But yeah, you could put a 1b, and 1b times 1b would be 1b squared, but 3 times 1 is 3, so I kind of didn't make a big deal about it. But you're right in that if that was like a 2b or a 5b, I would have had to have that in the parentheses, and it definitely would have changed things. But since it was just a 1b, yeah, I just kind of left it at b. Now, guys, I know it's silly because I have like the word cow. When I taught Algebra 1 to like middle schoolers, I don't know, this is a long time ago, I had like a really cute little cow face I put in there, but I just wrote the letters C-O-W just because I was like, I didn't want to find the cute clip part. I didn't really have time. But what I'm trying to show you is whatever you fill in the blank, whether it's a number, whether it's a variable, whether they give some random picture and then you have to do that, all I'm still doing is saying, okay, well, I mean, I'm a math teacher. There's a thing called cosine. I started to do that because cow isn't like a mathematical feature. But my college professor, he even in like this really crazy upper division class, used the idea of cow too to help some science majors, because science majors don't always like math. The math majors kind of made fun of the science majors because they didn't like math. It was okay, though. They did fine. And they went on to do amazing things. I have friends that are doctors and OBGYNs and all that cool stuff. But they didn't like math. So the professor was trying to explain to them function notation, because even college kids, they forgot what they learned in algebra class. And function notation it's a very big computer programming thing too. It's just saying f input. You put something into a function, and then output, you get something out. This one we put 2 in, and then we got out 11. This one we put a b in, and then I don't know, but there's the formula. We could have put a cow in, and whatever goes in there, whatever is in the parentheses is what takes the place of x, or whatever goes into the equation. So, this is the hardest one of the bunch. This is the hardest one of the bunch. And this is also the reason, or one of the reasons, that I have this poor little, like, puppy dying poster up here on my board. Because, number one, it's really hard once there's something besides, there's even, I don't know, it's even really hard when there's a number. A lot of you guys have forgotten what to do at the beginning of class. It's a little easier if it's a letter, but it gets way harder when there's a variable and a constant. It's hard to know where to put it, but wait a minute, don't you put it in the exact same spot we put everybody else? It's not a big deal. But what's hard is how you keep going. Guys, what's the very first thing we should try to do? We have three options. What are we going to do first? Squared. I mean parentheses, but if the x minus 1 aren't like terms. So a good idea, parentheses, I just can't do anything. So then squared would go next. Now here's the problem. A lot of people would do that illegally and they would forget, how do you square a binomial? You gotta FOIL it. And they would forget with FOILing, which you might use a box. That's one way. You might use actual first, outer, inner, last, but it's a huge mistake that I see everywhere from any kid who takes Algebra 1 till they graduate high school and even beyond. Because they forget that to square, you end up with extra pieces, and not just x squared and not just 1 squared, but you also end up with a 2x. Super huge mistake. That squaring took a lot of time because it was this x minus 1 guy. But as soon as we have that, we've squared, and now we just need to distribute. So you get 3x squared minus 6x plus 3 minus 1. We're so close. There's one like term. The only like term is 3 minus 1. And what's 3 minus 1 get us? Now, if you want to be super snazzy, maybe you try to factor out a GCF. But technically, we've plugged in and we've simplified so we can stop. But here's what I really, really, really want you guys to remember. This isn't something new. It's technically review. But as soon as we see this little f, as soon as we see a function f, we go looking for who is that guy. Oh, there he is. They gave it to us. And then we pattern every single plugging in from that function in the very beginning of the problem. We have to use this pattern. It's like a little baby program, basically. The function f is a little baby program. The little baby program can be used and plugged in for different operators or for different functions. Sometimes plugging in a 2, sometimes plugging in a b, sometimes plugging in a cow, that's weird, sometimes plugging in a binomial. But what I need you guys to see is, remember, that little f of is just saying use him as your program. Use him as your pattern. And what do we do with the inside guy? We plug him in, plug him in. So, what I want you guys to write, do you guys have a little bit of space above the input-output? Okay. We plug in the input and solve for, oh, my little work is in the way. My little foiling got in the way. Which hopefully makes sense. This word input-output is like a computer programming language type terminology. We plug in, who's the input? It's who we plug in, and we get out the output. So the cool thing is all along, every time we talked about X, he was always this little input guy, whoever was going in, and whenever we talk about Y, he's the guy who's coming out. So if you're sitting at a computer, and if, I'm trying to think of a good example, but these days you guys have everything so nice for the user, like with all the interfaces and everything. You don't see all the work that's going on behind the scenes. Can you think of any example in technology where you put something in and you get something out?
Calculator.
Yeah, kind of, right? But then you're like, you're kind of telling it everything though. Like
Investing money.
Huh?
Investing
Computer
money.
I'm
coding.
seeing coding, yeah, but not a lot of people have done that though, but yeah. Investing money. You kind of think of that. Like if you put a certain balance or a certain amount of money into like an investment, you're not the one that's making the money change, right? It's the investment itself that's making like the value go up or the value go down. So you're putting in the money and then stuff is changing. That's kind of like a real world example.
Right.
But I was trying to even think like a computer program. If you type something in, something happens to it and it comes out. You guys don't see a lot of it these days. But yeah, if you do any computer programming, you would understand that a little bit more. But yeah, you're putting in and you're getting out. We could talk about like grades and stuff, but that's probably a little too depressing right now. As far as what you put in, you get out. Or at least it affects it. But hold on. We started 10.3 4? Is that where we're at? Yeah, the final section of chapter 10. We got here really fast. We skipped 10.2. We did 10.1, 10.3, and 10.4. That's it. That's all we're doing from chapter 10, which means we have a test coming, but it's Friday, so we have all week to work on it. We're gonna do 10.4 today and tomorrow. Review Wednesday, Thursday, test Friday. That's another reason why I said the quiz needs to be made up by Wednesday, or else you're taking it Wednesday in class. Anybody who was gone on Friday, most of you were here. A couple people missed it, though, because everybody's getting their quizzes back Wednesday to study. But when you guys were doing the 10.3 worksheet, before we totally leave it, did anybody see, look at your worksheet real quick, the puzzle time. I'm going to come around and grade it. Did you see any problems that look kind of like these? Do you see any that look kind of similar? I was asking for where it got hard. Does anything look kind of weird like this? How are these so different than the rest of the worksheet? What was going on in these beginning ones or even the harder ones that all of a sudden changed when you got down to N and O? I thought N and O got way harder. Why did N and O get way harder than the rest? Nobody? Okay. If it's not hard, then let's just pause. Maybe you guys are totally good and you don't need to see this. I was just worried that N and O, we had never done anything quite that crazy in class. But hold on. Let me see what you did. In N and in O, what'd you guys do to both sides? Oh, not yet. The 6 is stuck. No, but it's the common mistakes. Actually, thank you, because a lot of people made that mistake on Friday in the quiz. Not everyone, but if they made a mistake, it was usually they tried to, let's add, instead of saying, no. What's the very first thing we have to do? Because the square root is already alone. I need to get rid of it. I can't get to the 6, the minus 6, or the times 7 without getting rid of the radical. So, if I square both sides, I end up with 7d minus 6, guys, but what's on the other side? Yeah, that's the hard part. Not 2d, because that would have been way easier. I wish it was. But it's d times d, or d. Did that happen anywhere else in the worksheet? Anywhere before n? No, you only had numbers. It was way easy at that point. Man, okay, what happens if we square this guy right away? Because once again, his square root is ready, right? 14 minus 5u equals what? Okay, that's why it got hard. So where we're at right now, Sean, is the puzzle time, grading it. And N and O, I thought, got way harder than the rest of the worksheet. Because right now, it's like, stink. How do I can't just get D alone. I have a squared and I have... This would make us go back and review chapter 9. I'm not going to go super crazy on reviewing. I am going to show you 2 ways to solve this one, though. Because remember last chapter we had the quadratic formula, we had complete the square, or we had factoring, or graphing. Now, I don't think any of us want to graph right now. No, thank you. So we have factoring if it's possible, the X method, or the square, or the formula. So I'm going to go ahead and, if it was factorable, we'd want to get everything on one side. If it's not factorable, we either want to do the quadratic formula, or to be honest, most of you guys are way better at completing the square, as I was grading your tests this weekend. Most of you guys were way better at completing the square. So, my question to you is this factorable? Can I do the X method? Is there anything that multiplies to be negative 6 and adds to be negative 7? 1 and 6. But wait, wouldn't I need a negative and a negative? Which works when I add it, but what happens when I multiply? Wait, did anybody realize that I did kind of silly math? How do you get 6 to the other side? Oh, thank goodness. That makes life a lot easier. Whew. We were about to have to do the quadratic formula or complete the square. But the nice thing is we don't have to now because it was such a nice factoring problem. Double check it once again. Negative 1 plus negative 6 is negative 7. Negative 1 times negative 6. Does this work?
Yeah.
Good. And if you guys remember, this is one of those with a 1 in front that's super easy. D minus 1, D minus 6. equals 0. And some of you remember, or some of you would have to show the work, that we flip that sign. It's opposite what we think. We set each one equal to 0 and solve. Whew, let's not even worry about complete the square, because he was nice. He was the X method. He was nice. He was the X method. But do you guys see how N was harder than I think all the rest of the worksheet? You had to factor at the end. Like, how gross was that?
Pretty gross.
Yeah, it was a little bit rough. I agree. This one would need the same thing in order to solve. I just figured most of you got stuck on N and O and kind of figured out the phrase and just went with it. Hence why we're looking at these two. If you guys have any other questions on the worksheet, have them ready and we'll get them answered in just a second. We would need to move everything to one side if we wanted to try to factor. We would have to also move the 14. Remember, none of these are like terms. So I can't be combining a u squared with a 5u with a 14, so I just have to keep them all separate. What do you guys think? Anything nice with these guys? Oh, yeah. But with 7 and 2, which one's going to be a negative? Because 7 minus 2 is 5, and 7 times negative 2 is negative 14. Is this one of those nice ones with a 1 in front?
Yeah.
Nice. Which means I can go straight to my factors. But can you guys look at your answers really quickly? Were the answers negative 2 and 7? What'd you make the match with letter O? I see Jeremy has me. Does anybody else have me for letter O? Alexis has me. What were those answers? Is that negative 2 and 7?
No.
Oh, the signs are different. Wait. Shouldn't we know that the signs are different? Whenever you're on the inside, isn't it opposite than what you think? And if you need a quick reminder, remember, we can also do Moses split the Red Sea. We can also set each one equal to 0 and say, wait a minute, who are you again? Oh, that's right, you're a plus 2. And you're a minus 7. Or I should say negative 7. So at the end of the day, what was mine? Did you hear about Bedeco had so many older brothers that he always got the hand-me-downs? Huh? Poor guy. That's right. These puzzles, they kill me. All right, so anyway, how'd the math go? So, were there any other problems that you guys got stuck on? Now that we figured out N and O, I thought they were the hardest, but I'm not saying nothing else was hard. Is there anything else you wanted to see? No. Oh, the ones up above. We didn't do a lot of practice. Can I ask you real quick, how did you do K? Did you figure him out?
No.
I'm not going to give you any B's on the test or on the quiz, but they were on the worksheet because the worksheet was from the book. What was different about the radical in K and L and M? Cube root. Now wait a minute. How did we get rid of square roots? What did we do to both sides? We squared it. So what are we going to do for cubed roots? Cube it. So we can go ahead and raise this to a third power. We didn't get to really see it in class. Hence, Melanie, totally makes sense why you were confused. But it's the exact same procedure of how do you undo a root? You raise it to the root's power. So 7 times 7 times 7 ended up being 243?
Yeah.
343? Oh, it's so close. I was doing mental math. It wasn't good mental math. Okay, so 343. Oh, that's fine. So, Melanie, let's practice that same procedure with these guys. So I'm going to do what power on both sides? You see it? Now, it's kind of hard because when we were working with radicals, not everyone understood that this was technically, we never wrote it, but it was technically a squared root. We just never wrote it, it was understood. Does that make sense? So every time we would do the squared, we were actually getting rid of the squared in the root with the squared on the outside. And we were getting down to whatever was underneath. So we're using the same idea. It's just confusing in your head probably because we never showed that understood squared. Okay, makes sense? Yeah. So now, once that radical is gone, well, it's going to get a lot easier because it's 17 minus. Now, careful. You're not going to be able to do just negative 2 times negative 2, not just squaring. You have to go all the way, which means multiplying it a third time, so you're going to end up with a negative 8. And then over here, actually this one might even be easier because you don't have to actually cube any numbers. You're just getting rid of both radicals. So this one actually might be a little bit easier as soon as you realize you were allowed to get rid of both radicals at the same time. Does that kind of make sense where to go? Yeah. Any other places that you guys got stuck on the worksheet? H? Let me go again. Oh, H had a lot of big like values and numbers, huh? A lot of you, just knowing from the quizzes that I graded from Friday, which you can't get back quite yet, some people were absent. A lot of you really want to do that's 14, but we're not allowed to make it 14 because multiplication in PEMDAS has to come before addition. So I can't go making that 14. Armando, is this worksheet all the way done? Okay, we just did 1, 2, 3, 4, 5. We're about to do 6 of the problems together in class. So if it's not done, you should probably be following along. Yeah, we're on H right now. So why don't you try to do it with us? So for number H, I can't make that 14 totally illegal. I can't go getting under the radical because the radical, remember, is like a little prison. It traps that inner function, that argument. So the only thing I can do, Jonathan, ready? You guys subtract that 10 first. I gotta go piece by piece, undoing the PEMDAS. And then I'm going to end up with 4 radical. Andrew Everett's too loud. I know, I was just saying too loud. So if you can hear it. As far as whispering. Then I have my square root of 4p minus 15 is equal to 9. Now is the proper time for me to bring in that square to undo the square root. So you have to go in the right order. That's what's so important about PEMDAS. And in solving equations, we're trying to get to that p, but we start with everybody who's farther away. And we start kind of picking off the people little bit by little bit, subtracting the 10, dividing the 4, getting rid of the radical. And now it's just time to do a quick addition like we know to do. And then do a quick division. Which I'm going to do a little 2-column division in my head real fast. 4 goes into 9 2 times. That's 8. 9 minus 8 is 1, 16. And I think you guys should have been trying to match it to p equals 10. Oh, the last one is the word one, huh? Okay. So that word one here at the bottom is talking about the circle. And the radius of a circle, you guys haven't taken geometry yet, most of you, so you might not know exactly all the pieces of a circle, but the radius of a circle is this half measure that you can have go all the way around and make the entire circle with something known as a compass. But it's just telling us that there's this equation with an r in it that means radius. That's about it. There's an equation with an r in it that means radius. So it says, hey, can you find the radius? Can you find r? Guys, what have you been doing the whole worksheet? Haven't there been problems with variables and we're trying to get the variable alone? That's exactly what we're doing in P. And so it's like N and O in that it's the nasty ones where when you square both sides, you're going to end up with a quadratic, like chapter 9. So Jeremy, if I were you, I would try the X method because it's been working pretty good today. So the X method says get everybody to one side with a 0, right? So I'm going to go ahead and get this guy over. I'm trying to move everybody. The nice thing is I get my 0 equals. And we could try the quadratic formula. A is 1, B is negative 12, C is negative 13. But some of you are like, oh, it's going to be awful to plug in. If the X works, it might shorten our work a little bit. To where we might be able to solve it pretty fast. So negative 13 times negative 1, negative 13 plus 1. So a lot of review math going on here with our factoring method. But there is that other way if you guys like it. Just a quick reminder because some of you are actually really rocking that complete the square. You could have also made the square. Because this one's a nice negative 6 and negative 6 with a 36. could have added the 36 to get r minus 6 squared, and added the 36 to get a 49, and then square root both sides. You could have gotten r minus 6 is equal to 7, so r minus 6 equals 7, or r minus 6 equals negative 7. I know not everyone loves this method, but some of you were really doing so well on it on the test. I thought I'd show it to you because some of you might have been able to do this a little bit faster using that method. Because remember, with the x method, you're not done yet until you set each one equal to 0. So positive 13, negative 1. We're having to keep going. Everest, what's up, bud? Yeah. Okay, you guys have done an awesome job asking questions on the worksheet and showing me where it got hard. Where did it get hard? I think with the cube roots, those got hard. And then anytime we had a quadratic pop up randomly, I had to be like, oh no, quadratics. Some of you forgot, we just did a whole chapter on quadratics with so many different ways of solving. But the X method really was one of the easiest. A lot of you guys have this ready to grade. So I'm going to kind of pop around the room just a little bit, but we are supposed to be doing, there we go, section 10.4, which we did already do those beginning problems, but I want you guys to go ahead and look at the following. Because we need to go ahead and just peek. And actually, guys, the homework really isn't that bad if you get the idea down. What we've been doing so far is we basically, in this worksheet, talked about, hey, the X guy, he's the input, he's who we put in, and the E is who we get out, the output. Like in letter A up above, we put in a 2 and we got out an 11. But in inverse, I need you guys to find the word inverse. I need you to box it, okay? In your worksheet 10.4a, you box the word inverse. Actually, let me do that in a highlighter. I try to do highlighters with really important ones. If you guys take notes, this is a really important note to get down. Inverse relations say, I am going to switch. We switch the inputs and the outputs. Inverse says, let's go backwards. Kind of like PEMDAS, and we just did that with lots of equation solving. And that PEMDAS says, parentheses, exponents, multiplication, division, addition, subtraction. But when we're solving, we actually do addition, subtraction, then multiplication, division, then exponents, then parentheses. We go backwards. That's kind of what inverse does. It goes backwards. Now, you might think this is super crazy hard, but check it. Don't they give us a list in 1 and 2 of the inputs and then of the outputs, right? What do you guys think we're going to do in the table if it says find the inverse? What's the inverse going to do? Yeah. Not opposite, but switch. If it's easier, you might say flip. Meaning, 1's going to go with -4 still, but 1 is now the input. -4 is now the output. Instead of putting that in and getting that out, we're going to put in a 1 and get out a -4. Well, wait a minute. Hold on. Are all the outputs going to become inputs? Yeah, because they're all going to switch. Oh, guys, this is easy. All the inputs become outputs, and all the outputs become everything just switch. So you guys could probably rock the next one, right? Inverse just says, hey, we're going backwards. Inverse just says, hey, we're going backwards. Inverse just says, hey, we're going backwards. So in numbers 3 and 4, hold on. If I were you once again, same way that you just need to know that inverses switch, we're going to kind of do the same thing in an equation. It just gets a little harder in an equation. We're going to solve for the input, plugging in the output. Now, this is a little weird. Do you guys see in the directions, what does it say? Does it say solve for x? Okay, solve for x. Solve for x, but x is right here. Okay, well, how do we get x alone? Don't we just subtract 4? So now we have f of x minus 4 is equal to x. Guys, when it says the output is 2, we're going to put that 2 not in the X spot. That's the input spot. That's how we started class. We're switching, and instead of putting it in the X spot, we're putting it in the Y spot. So what's weird today is that you're going to solve for the X and then plug into the other spot. What's X going to equal?
2, -2.
Close, negative, because the 4 wins. So the tables are pretty easy. You guys can check and see if you did that right, but hopefully you just took all of those outputs and made them inputs. Those are pretty easy. Switch all the X's with the Y's. What were X's? What were Y's? Totally switched orders. But when it comes to equations, it's going to look a little funny because you're used to getting Y by itself and then plugging in. This time we're getting X by itself and then plugging in. And it might even be easier if you guys take it step by step and even write it a little differently than you're used to. Divide by 3. Now this is going to be a little weird. Dividing by 3 is going to look a little funny. If you want, you could write this in a little bit prettier way with the X on this side. But what you need to realize is what we're doing is we're taking this output and we have to get X alone and then we get to put this guy in. So he's taking the place of the entire f of X. And that's how we would get 2 plus 2 over 3, which PEMDAS would say is 4 over 3. Does it feel weird? Kind of. But does it feel weird? Maybe kind of not. In that you guys are kind of used to solving for X's. It's just we're putting this into a different spot. We're putting him into the output spot. But it only is going to easily go in once we rearrange the equation. So did anybody keep doing number 5 as we're in our last few seconds of class? What did you guys do for number 5? You subtract 2. Good. You got 1/3 X is equal to f of X minus 2. Then what? How do I get rid of the 1/3 though? Close. I think it'd be easier to multiply by 3. So I get X equals 3 times. There might be different ways of getting it. Did anybody realize it would just be 0 though? Because when you plug it in, what's 2 minus 2?
0.
And even with that 3, well, I don't have much hope if it's a times 0. Because anything times 0 is itself. If you guys haven't written it down yet, back on the board, page 572, you're just switching inputs and outputs. And you're kind of solving in a backwards way. You're getting X alone and then plugging into that f of X spot. I already looked it up. Sorry, but you get my desk. All right, guys, I'm going to go ahead and grade the worksheets tomorrow. We ran out of time. Excellent job today. Have your puzzle times.